In Italy, a towering bridge suffers a catastrophic failure.
There was no warning and nothing anyone could do to stop it.
Tragedy strikes a Connecticut construction site.
The building was totally collapsed, as if a bomb had gone off.
In Canada's capital, devastation as a bridge fails mid-construction.
Boom, everything went down. So you didn't even have a chance to move.
And in Australia, a legendary icon that's been getting critical reviews.
It's always been quite controversial amongst musicians and performers.
With big builds, even the smallest mistake can be a huge disaster. From miscalculations to misunderstandings, some with deadly consequences. These catastrophes are every engineer's worst nightmare. With big construction, engineers are constantly pushing boundaries with bigger and bolder designs. But if things go wrong, the results can be catastrophic. Like this disaster in Italy, a devastating failure on a vital crossing.
Diciamo, la scena che si è presentata è difficile da descrivere. La percezione della tragedia, del dramma è stata immediata.
A shocking bridge collapse that brought a city symbol crashing down to earth.
Incredulità. È come se crollasse una montagna. È impossibile.
And a tragedy that left a nation reeling.
This was one of Italy's deadliest ever engineering disasters.
Genoa in northern Italy is one of the country's most historic ports and the birthplace of Christopher Columbus. Like many local residents, Giuseppe Leonardi is proud of his city's long-standing maritime traditions.
Genova è sempre stata una città sul mare e continua, seppure diciamo con sistemi ovviamente consoni all'epoca che stiamo vivendo, ma continua a vivere per il mare e con il mare.
As Genoa's economy and population grew, its aging infrastructure was struggling to cope. So in the 1960s, engineers built this, the Viadotto Polcevera, or Morandi Bridge. At the time, it was one of the longest concrete bridges in the world. Brian Aietto is a structural engineer and journalist.
Genova stava subendo una trasformazione. Quindi, quando commissionarono all'autostrada questo grande ponte, per Genova era una rinascita.
Opened in 1967, the Morandi Bridge towered high above the city, carrying traffic on one of the busiest highways in Europe. And soon became a landmark, defining a new era of Italian engineering might.
Ponte Morandi era un'opera così mastodontica, usava così tante tecniche innovative che è stato paragonato al Golden State Bridge per l'Italia.
This nearly 1,200-meter-long cable-stayed bridge stood out thanks to its bold and daring design. At each 90-meter-tall tower, the road deck was supported by just 4 giant steel and concrete cables. Vincenzo Nunziata is a structural engineer.
Lo strallo che cos'è in effetti? È un tirante che serve a sostenere in un punto l'impalcato. In questo caso il pilone o il pilastro, che è fatto in un certo modo nel viadotto Morandi, serve a trasferire i carichi dall'impalcato in fondazione. Normali sono costruiti solo con delle funi in acciaio. Questi invece sono dei tiranti che, oltre ad avere delle funi in acciaio, sono rivestiti con una guaina di calcestruzzo precompressa.
The idea was that the bridge's concrete structure wouldn't need any maintenance, and neither would the steel, because the cables would be protected from the elements by a concrete coating.
When the viaduct was designed, steel was in short supply. By using pioneering techniques to combine the two materials, engineers built a structure that was lighter than its steel predecessors, yet, in theory, just as strong.
For more than 5 decades, this eye-catching bridge carried millions of people every year. But a sudden and devastating catastrophe was about to make this majestic crossing infamous around the world. Tuesday, August the 14th, 2018. The city of Genoa was waking up to a huge summer storm.
By 11:30, the rain was so heavy that visibility had dramatically fallen. The bridge was covered in a grey mist, forcing vehicles to slow down.
Moments later, disaster struck. Footage captured by security cameras showed a nearly 200-metre section of the bridge collapsing, along with one of its 3 supporting towers. Unable to stop, vehicles fell around 45 metres to the ground. President of Genoa's Red Cross, Giuseppe Leonardi, received a call that the bridge was down.
Tanto nessuno di noi immaginava una cosa di questo genere. E quindi la percezione della tragedia, del dramma è stata immediata.
When Giuseppe arrived on the scene, his worst fears were confirmed.
Diciamo, la scena che si è presentata è difficile da descrivere. Comunque, diciamo, le macerie erano dappertutto Vi chiedo scusa, ma...
The symbol of Genoa and Italy's engineering prowess was in ruins. But incredibly, one truck on the bridge had managed to stop just in time.
L'autista, ho sentito poi raccontare, è corso indietro verso la galleria per avvisare il più possibile quelli che sopravvenivano di fermarsi. E forse il suo intervento è stato fondamentale per salvare la vita di molte persone.
While the truck driver's quick thinking had probably saved lives, dozens of vehicles had already gone down with the bridge. Tragically, 43 people died.
La scena che si è presentata era una scena che ritengo di non essere capace di descrivere nella sua tragicità, nella sua realtà.
This was one of the worst engineering disasters in Italy's history, and the nation demanded answers. Italy's Prime Minister declared a 12-month state of emergency, and an investigation was immediately launched. Attention quickly focused on the revolutionary sheathing encasing the cables. The pioneering use of more concrete and less steel had created a problem.
Concrete is great in compression, handling heavy loads pushing down on it, but unlike steel, it's not so great in tension with loads stretching or pulling on it.
By using less steel, not only have you got less strength under tension, but because the steel is encased in concrete, you can't inspect it unless the concrete cracks, and by then it could be too late.
And when the concrete did crack, the viaduct's location, in a busy industrial port with polluted and salty sea air, would only make things worse. Exposed to the elements, the crossing's signature structure was slowly being eaten away.
Cracks in the concrete casing meant that the steel inside was corroding. hidden and out of sight. The very thing that was meant to be protecting the steel was in fact slowly destroying the bridge.
With millions of vehicles crossing every year, and after more than 5 decades of deterioration, the bridge suddenly and tragically gave way.
C'è chi dice che si è rotto lo strallo, chi dice che si è rotto prima la trave, alla fine comunque si è rotto un qualche cosa che ha comportato che l'antenna ha comportato, diciamo, come se fosse diciamo, una costruzione Lego, cioè tutti gli elementi che componevano la struttura, quindi pilone, antenna, cavalletto impalcato, come un sistema, con una rottura a catene, in effetti è crollato un intero ponte.
It turns out the signs had been there for years.
More than 25 years before the collapse, the concrete encased cables were already heavily corroded. But instead of replacing them, the decision was taken to add extra cables around the outside.
Chi ha studiato un po' ingegneria civile sa che le strutture non crollano all'improvviso, avvisano. Un edificio in muratura mostra lesioni, una struttura in acciaio si deforma tantissimo, così come una struttura in cemento armato. Le strutture, se osservate, ci parlano, a volte gridano il loro malessere e può questo grido durare per anni. Sta a noi ascoltarle e intervenire prima che l'inevitabile accada.
While the judicial case is ongoing, in December 2020, it was reported that the inquiry is focused on both design flaws in construction and poor maintenance as the most likely causes. The recovery and cleanup operation was huge. Nearly a year after the disaster, the 2 remaining spans were finally demolished, and work began on the new crossing.
Construction crews worked round the clock, and the new bridge was opened less than 2 years after the tragedy.
With the new bridge, the spans are entirely supported from beneath by 18 giant concrete piers. Although the new crossing was born of tragedy, 43 lights will serve as a constant reminder of the 43 people who tragically lost their lives.
Il ponte ormai era uno dei simboli della città, no? Di cui si andava anche orgogliosi. Quindi ci ha colpito tutti.
Spero che il Ponte Morandi il lascito del Ponte Morandi, di questa immensa perdita, ci ricordi l'importanza di prenderci cura di quello che abbiamo, che è inestimabile e unico, e come mi piace a volte dire, è il nostro onere e il nostro onore.
With big construction, how you build can be just as important as what you're building. One small mistake can trigger a major catastrophe. Like this project in Connecticut that came crashing to the ground.
Without any warning, both buildings totally collapsed.
This was one of America's worst ever construction accidents.
A tragedy that tore through the heart of a community.
You had workers trying to rescue their own. It was like Armageddon.
This catastrophe changed the American construction industry forever.
Engineers have come to recognize the risk just isn't worth it.
Bridgeport, Connecticut. Once a whaling and shipbuilding town, this historic seaport has become a cultural hub. Lenny Grimaldi is a local journalist.
Bridgeport is Connecticut's largest city. It's situated about 50 miles north of Manhattan. Bridgeport's known for its beaches and parks. There's a new buzz in Bridgeport right now because it's becoming an arts and entertainment destination, driving a lot of new people here.
But this thriving town hasn't always had it so good.
In the 1970s, Bridgeport was suffering from mass unemployment, rising crime, and people were choosing to leave. But in the 1980s, there were hopes that the city would turn things around with new construction projects.
In 1986, construction began on a luxury apartment complex to breathe new life into downtown Bridgeport.
So this was a period when Bridgeport was trying to reinvent itself with new housing downtown because there was very little housing in downtown at all. So there was excitement built around the construction of L'Ambiance Plaza.
The new project consisted of two 16-story towers slightly offset from each other, with 13 floors of apartments sitting above 3 levels of car park.
The building's design was relatively straightforward, but what was interesting was how it was going to be built.
David Peraza is a structural and investigative engineer.
It was built using the lift slab method of construction. The general idea is that all of the concrete slabs for the floors are poured or placed at ground level, right on top of each other, like pancakes. And then once they're cured, once they're hardened, then they're lifted into place to their final destination in the building.
The entire process centers on a network of vertical steel columns. Civil and former Army engineer Stephen Ressler demonstrates.
This represents a steel column, which is sitting on a concrete footing. Once all of the columns have been constructed, the next step is to cast the concrete slabs. As you can see, when it's cast, there will be a hole in the center, a rectangular hole, and integrally cast within that hole is a steel fitting. It's called a shear head.
These steel shear heads are key to the technique, which uses high-powered jacks to lift the slabs.
The jacks are placed on top of each one of the columns, and from these jacks, 2 very heavy steel rods hang down, and they engage or hook into the shear heads in order to lift the slabs.
The hydraulic jacks are activated, and the slab is lifted up into its final position. Once the slab has been lifted, it must be temporarily parked in place using temporary steel wedges.
At each shear head, there would be 2 of these wedges that were installed in order to park the slab. There'd be one inserted on one face of the column and then another one that's inserted on the other face of the column.
And then these steel wedges are welded into position. The jack can then be removed. Once the builder is sure that all the slabs are in the correct position, the welders go back in and put permanent welds on those wedges, and then concrete is poured into this rectangular opening in order to seal the joint between the slab and the column, and then that particular phase of the construction process is complete.
These concrete slabs are hugely heavy, so precision and balance are key. Too much lateral movement and the whole thing can come down like a house of cards.
The lift slab process is fraught with peril. There are innumerable ways that the process can go wrong if it's not managed with extreme care.
April the 23rd, 1987. About 6 months into construction, workers were lifting the slabs for levels 9 to 11. Journalist Lenny Grimaldi was on leave when his newsroom called.
My answering unit was very, very loud and very, very clear. Lenny, your vacation's over. Get into the office. L'Ambiance Plaza has collapsed.
Mayor at the time, Tom Bucci, also heard the news.
I thought maybe 1 or 2 floors had collapsed. Never did I think the entire building collapsed. How could that be possible?
Both towers had crashed to the ground.
Some eyewitnesses said the building came down in as little as 2 seconds.
Tom and Lenny headed to the scene.
I got out of the car and saw the building was totally collapsed. And it was as if a bomb had gone off.
you had workers trying to rescue their own. It was like Armageddon.
The race was on to scour the rubble for the injured.
Workers from every site being built in Bridgeport and surrounding towns descended on the area and started digging through the rubble by hand. By hand, no machinery, by hand, trying to see if they could find a survivor.
22 workers were injured in the collapse. Despite everyone's best efforts, tragically, 28 people lost their lives.
L'Ambiance became the largest construction accident in the history of Connecticut. You had international media that came over from Europe and even Australia that were asking, why did it collapse? Was this an engineering issue?
OSHA investigators arrived on the scene the same day and called in the National Bureau of Standards to help establish what had gone so badly wrong.
At the time of the collapse, many of the slabs were in kind of a holding position until they could be permanently fixed in their final location. So investigators focused on the lifting mechanism.
Engineer David Peraza was part of the investigation.
Each building fell into itself. All the slabs collapsed, they pancaked. Most of the columns were very severely distorted, kinked. They were like pretzels.
With the lift slab process, the columns were key to jacking the floors into place.
There was one column that stood out and was different from all the others. It was just a very gently arched column that seemed to have fallen down on top of everything else, after everything else had collapsed.
Instead of being crushed by falling slabs, the column had fallen onto the wreckage.
It turned out that this column, in fact, was the key. This was the column where the collapse initiated. At this particular column, the shear head was too large for the column. So this allowed the shear head to move laterally so much that it lost its support on top of the wedges. And it was only at this column and another column that error existed.
Based on this evidence, investigators came up with two main theories to explain why the shear head had come loose.
The failure theory that was put forward was that these metal fixtures, called shear heads, while they were strong enough, were excessively flexible. So, under the weight of 3 slabs, and subjected to the jostling and movement associated with the workers attempting to move those slabs into their final position, the lifting rods slipped out of their slots on one of the shear heads. That shear head came loose and it dropped down, and the shear heads surrounding it were suddenly overloaded, and they failed in the same manner, and a chain reaction collapse ensued.
The second theory cited problems with the welds.
So, under the extreme load of a package of 3 slabs being lifted, some of those welds failed, the shear head came apart, and a single shear head failed. And then from that point forward, the sequence of failure would have been essentially similar to a chain reaction collapse.
Whether the ultimate cause was excess flexibility or faulty welds, failure of just one shear head was the trigger that brought down both towers.
As they were falling, they were pulling in the rest of the structure, almost like a funnel shape, causing it to collapse.
With such huge forces at play, you can't afford to have any weaknesses in the system.
In 1992, 5 years after the collapse, a new apartment building opened on the same site. And just 1 year later, a memorial was dedicated to the memory of the fallen workers.
The inscription on there says it all. In their honor, some good has risen where so many tragically fell.
If any good came from the collapse of L'Ambiance Plaza, it put the lift slab building technique in the spotlight and ultimately changed the industry for the better.
One of the lessons to take from L'Ambiance Plaza is that very small errors can have catastrophic results. In this particular case, a little detail resulted in the total collapse of 2 buildings. The collapse of L'Ambiance Plaza really signaled the end of lift slab construction in the US.
Engineers have come to recognize the inherent risks associated with the method and have come to recognize that despite the great economy that can be attained from the use of the method, the risk just isn't worth it.
Some engineering fails lie hidden for years before triggering disaster. But others strike while construction crews are still hard at work. Like this tragedy in Canada, a catastrophic collapse in the nation's capital.
This was one of Canada's worst ever construction accidents.
Boom, everything went down. So you didn't even have a chance to move.
An engineering error revealed with devastating consequences.
The falsework collapsed into a pile of rubble and wet concrete.
It was so loud that it registered 3 kilometers away.
Ottawa, Canada, was established where the Rideau and Ottawa rivers meet. It was once a small trading outpost known as Bytown, then became the nation's capital in 1867.
Ottawa was picked as the nation's capital because it was centrally located between Toronto and Montreal, and it had great transport links by water, by rail, and later by road.
And the city has been growing ever since. James Powell is a local historian.
In the mid-1960s, the federal government wanted to move out of the downtown core and to build new office structures here on the periphery of the city. So the federal government was very keen on improving transportation links out here.
Key to improving those links would be this, the Heron Road Bridge. Completed in 1967, it connected the city across 2 waterways that had once divided it.
It spans the Rideau River here and just further to the west, the Rideau Canal. One bridge for the eastbound lane, another bridge for the westbound lane.
When planning a bridge, engineers have to weigh up lots of different factors before deciding how to build it. What type of bridge is it? How high is the structure? How much space is there on the ground?
Here, the decision was made to build the bridge using 2 techniques. Engineer Tony Wing explains.
Well, the plan was to build a 7-span bridge out of concrete. They were using 2 different type of concrete structures. In 4 of the spans, the plan was to use cast-in-place post-tension concrete. And in the other 3 spans, the plan was to drop precast girders into those spans once these 4 spans had been constructed.
Because of their massive size, the 4 main spans would be poured in place into wooden molds temporarily supported by what's known as falsework.
The falsework was made of wooden members that were nailed and bolted together, creating a vast latticework box to support the steel and wooden molds for the new spans above.
What I've got here is a model that I've put together of the falsework of the Heron Road Bridge. So in this model, we have transverse frames that go across the bridge. We've got 2 of them in red, and we have longitudinal frames that go the length of the bridge. Without the falsework, you could not build the bridge.
But with the falsework in place, construction could start on the spans.
You pour the wet concrete into the form. At that point, the concrete does not support itself. It's all supported by the formwork and the falsework, and you have to wait for that concrete to harden.
Crucially, they had to bear their own weight, the molds, construction equipment, and finally, all the concrete for the new structure.
Wednesday, August the 10th, 1966. Construction was well underway on the cast-in-place spans.
The westbound lane was finished, was completed without any problems. The eastbound lane was half completed.
It was a warm summer afternoon. About 70 workers were on the structure, preparing for one of the job's big concrete pours, a huge 2,000 tons in all.
Mike LeCure was a rookie, working his second shift on the bridge.
I was 18 in my first construction job. I came down here on a Tuesday and I was assigned to work on this span here on the north span.
They were constructing the third cast-in-place span, which was much higher than the previous two, so the false work was much taller.
I went up and started shoveling the cement, and they were working with two of the large cranes and the big pots of cement to finish this span right here.
With cast-in-place structures like this, pouring the concrete is the most dangerous part of the project. For the first time, the false work has to withstand all that extra weight.
I remember looking up to the, down further, a little down further that way, and there was something like moving on the bridge. Well, what was happening was the bridge was starting to go, and things were starting to roll. But then, just like that, boom, everything went down. So you didn't even have a chance to move.
One witness said the entire span just flipped over, smashing everything beneath it down to the ground.
I fell the equivalent of 5 stories, and I went with all the cement, reinforcing rods, lumber, and all the rest of the debris that was up where we were working.
The false work collapsed into a pile of rubble and wet concrete and reinforcing into the valley floor.
And then I realized what had happened, and I realized I was still alive. But luckily for me, I wasn't knocked out, because if I had been knocked out, I would have been dead.
Rescue crews, workers and passers-by all helped to dig the victims from the wreckage.
Absolutely total chaos. Fire department, police, priests, even the mayor was here helping out.
A buddy of mine was up at the other end, and I knew he was there, and we had to find him, eh? So another friend of mine came from this span here, and he found me, and we kind of tended to, getting the cement out of my face, because I couldn't hardly see, because it was in your nose, in your mouth, because they kept pushing me down and down. Right? We eventually did find my buddy, and he sustained a pretty good gash in the back of his head. Luckily, he was at the lower end for him, but he had just come from this end here, and he left his buddies, and the buddies that he left, all of them died.
More than 60 workers were hospitalized. Tragically, 9 men died from their injuries.
Nobody was prepared for it. It was pretty horrendous.
The catastrophe left a nation shocked and in mourning. The Ontario government immediately launched an inquiry.
One worker who was cleaning a crane said he heard a crack, looked up, and saw the wooden false work start to bend before the whole lot came crashing down. That was a crucial clue for the investigation.
Investigators discovered a key piece of the false work was missing, as engineer Tony Wing demonstrates.
When you want to brace something, you brace it with cross-bracing or triangular members. If you try to deform this triangle, you can't. So engineers use triangles in their construction to brace members. In the Heron Road Bridge, they use lots of those in the transverse direction, but in the longitudinal direction, you see a complete absence of diagonal bracing. There's none whatsoever. All we have is horizontal bracing.
Horizontal bracing alone left the false work vulnerable to deformation.
When you're pouring tons of wet concrete into a mold, the forces aren't just acting downward. There's a lot of sideways, lateral movement too. And here, the false work just wasn't able to cope.
This is what happened during the collapse. Those horizontal loads caused the bridge to sway, come off the vertical, and then all of the red members, the vertical members, simply buckled, and the frames and everything came down in a mass into the valley, along with the concrete that was being supported temporarily by this structure.
With this one weakness, the bridge was doomed to fail before it was ever complete.
Simply put, had they been in place, the falsework would have been stable, and the concrete on top would have stayed in place, would have hardened, and it would have been a success.
Using redesigned falsework, construction continued on the bridge. And just under a year after the tragedy, on June the 29th, 1967, it opened to traffic.
Every time I cross the southern span here, I think about what happened 55 years ago.
In 1987, a plaque was erected to honor the victims. And 50 years after the collapse, the bridge was renamed the Heron Road Workers Memorial Bridge.
The guys that gave up their lives here, they should never be forgotten. Something I will never forget, and I don't think anybody in Ottawa will ever forget, like the carnage and the pain and the suffering. So it kind of hits you when you look at it again.
You have to have adequate design of the falsework so that the safety of the public can be ensured.
With standout structures, engineers walk a fine line between form and function. There's always a risk the balance will tip too far in one direction. Like this story in Australia, with critical reviews of one of the world's most iconic concert halls.
Performers and the audience have long said the acoustics could be better.
There's not enough room for the sound to get out.
An issue that has reverberated for half a century.
It's always been quite controversial amongst musicians and performers.
This just goes to show looks aren't everything.
Sydney, Australia, is regularly voted one of the most livable cities on Earth. It's also one of the most iconic, thanks in no small part to this, the Sydney Opera House. Journalist and author Helen Pitt has long had a passion for the groundbreaking structure.
The Sydney Opera House is probably our most beloved building in Australia. You look at that picture and everyone can immediately place you in Sydney. It's become our international calling card.
There are few buildings on Earth as unique and iconic as the Sydney Opera House. You wouldn't know that it was designed more than 60 years ago.
The now famous shells were first conceived in the 1950s in response to an international competition.
The competition attracted a host of Europeans, including a Dane who was entrant 218, so he's a little late in terms of the competition entries, and a fellow Scandinavian is said to have picked up this one and with a flourish turned to his judges and said, "Gentlemen, here is your opera house."
With the winner picked, now came the biggest challenge, building it.
This is a world-class opera house, and the audience would expect a world-class view. So there could be no columns between them and the stage.
The concrete skeleton inside the infamous shell design would have to be entirely self-supporting.
When the Opera House was conceived, nothing like this had ever been built. It took 4 years to just figure out how to make the shells strong enough to support themselves.
The engineering was seriously complicated, and the project was far from plain sailing.
It was budgeted to take a couple of years and $7 million. It took 17 years and cost $102 million.
Finally, in October 1973, the project was complete, and Queen Elizabeth II officially declared the Opera House open. Although striking from the outside, the real purpose was to sound good on the inside. Acoustics expert Professor Denzel Cabrera has extensively studied the Opera House.
The main purpose of a music auditorium is to send sound to lots and lots and lots of people. And the auditorium contains that sound. And as well as making the sound loud enough, it also provides a reverberation, which many people find beautiful and enhances the quality of certain types of music.
Getting the acoustics right is like mixing a highly complicated cocktail, balancing materials, geometry, physics, even neuroscience. so that the audience can enjoy the best possible acoustic experience.
Although it was 17 years in the making, in this one crucial quality, the Opera House started to receive mixed reviews.
The Opera House is clearly a very inspiring venue to attend, as well as the dramatic exterior, and the sound is pretty good. It could be better though.
So it's always been quite controversial amongst musicians and performers, the actual things that it delivers acoustically.
The obvious question was why. It all comes down to a decision made years before the Opera House ever opened its doors.
The original plan was for the opera to be in the larger shell, but at the time, symphonies were more popular than the opera, so the decision was taken to swap the two. Ultimately, neither was the right size for the job.
The trademark shell design added to the complications.
The issues with the concert hall stem largely from trying to fit a large concert hall into the limited space that was available underneath the shells. So that makes the concert hall a little bit narrower than perhaps it should have been. There's also a very high crown in this auditorium, so the sound from the stage going up to the top, the ceiling, and back down to the stage creates an audible echo.
The problem wasn't just in dimensions, but in shape too.
Adding to this issue is it has a ceiling shape a bit like a hat. And so we have these areas around the edges that have quite low ceiling. And that means that the seats underneath those low areas don't get the sound that's reverberating around the upper part of the auditorium.
As well as the overall size and shape, specific surfaces compounded the acoustic confusion.
The original acoustician put in 90-degree sawtooth surfaces to reflect the sound back to the stage. This is a phenomenon known as retroreflection. The reflectors have to be big enough to reflect the wavelengths that we care about. But unfortunately, they'll only reflect high frequencies because the sound wavelengths in the mid and low frequencies are much too big.
The issues weren't limited to the concert hall. The smaller theatre had a major problem for the audience and performers alike.
The opera theatre orchestra pit is notorious because it's kind of buried underneath the stage and there's not enough room for the sound to get out. So it's too loud for the musicians and not loud enough for the audience.
Ultimately, although a monumental visual success, Sydney's prize landmark has never quite hit the same heights with its acoustics.
The Opera House opened nearly 50 years ago, and over the decades, various fixes have been tried. But in 2020, to try and sort the acoustics out for good, this icon actually closed its doors for a 2-year mammoth refit.
One of the modifications that's being done to the concert hall is increasing the surface area of the reflectors. This will reduce or eliminate the floor-ceiling echo and also provide the musicians with a better lower mid-frequency, maybe a warmer sound. They'll be able to hear each other better.
And the troublesome sides of the stage have also been reconfigured.
The faces of the vertical elements around the stage, these have been replaced just recently with wavy surfaces. Wavy surfaces provide a diffuse reflection, which means that the sound comes from a large surface area in a diffuse way to a listener, rather than coming as a chunk from one direction all at once.
When this huge renovation project is finally done, the hope is that Sydney's iconic opera house will sound every bit as amazing as it looks.
I still feel it every time I fly in and out of this beautiful city. I don't see the Sydney Opera House, I see my Sydney Opera home, and that's what it means to most Sydneysiders. It's not a house, it's our home.